Okay, picking up where we left off, we were talking about the smoothness. It's continuous everywhere, because this derivative is defined everywhere, but it's not, in order for it to be smooth, the derivatives can't be zero. So it looks like these are zero at every pi over 2. 0, pi over 2, pi, etc. So how do we represent that? I would probably call it this. R prime of t, or r of t, is smooth on the interval n times pi over 2 through n plus 1 times pi over 2. I know this is messy. Let me turn this sideways and rewrite this. Pi over 2 times n through pi over 2 times n plus 1. So basically, as you go from 1 pi over 2 to the next, so from 0 to pi over 2, for all n an element of the integers. So how do you read this? RT is smooth on the interval pi over 2 times n to pi over 2 times n plus 1, bounds not included, for all n on the element of the integers. I think the shape is something like this. I'm not 100% sure, but so the parts where it's not smooth, it's really kind of hitting spikes. Okay, let's move on to another problem. For r of t equals 1 over ti minus j plus ln of tk, and u of t equals t squared I minus 2tj plus k, find the following: a dot product and a cross product. The notes are already up online. We'll do the dot product. The derivative of r of t dot u of t. So let's do the dot product here. So dot product, I'm multiplying components. 1 over t times t squared is just t. Negative 1 times negative 2t is 2t. ln of t times 1 is ln of t. And I need to take the derivative of that. Okay, so we have t, 2t, and ln of t. What's the derivative of this thing? We'll take the derivative of the components. Derivative of t is 1, 2t is 2, this becomes 1 over t. So the derivative of that thing would be the function, or the vector 1, 2, 1 over t. Now you can do the cross product one. It's just a little more work. Now, if definition of integration of vector value functions, if r of t, okay, so integration, much like the derivative, is component-wise. You can integrate each component and get the integral overall. Now, one thing to note is that when we integrated previously on indefinite integrals, we had constants, usually just the plus c that happens on all things. These functions are all separate, so you're going to have to ask yourself the question, could they all have constants? So let's talk about the integral of ti plus 3j dt. The integral of t would be t squared over 2. In your head, it would be plus c. What about the second one? The integral of 3 would be 3t plus, we'll call this dj. So is this a thing? Do they each have a component? I would assume the answer is yes. Just like when we do definite integrals in the past, it would get subtracted off. Here, if you were given an initial value or were given an antiderivative, you could work with. But for now, I would say you have to have the constants. It's just like integrating a function with x and having the plus c on there. You don't know what's happening with that vector. All you know is what the derivative looks like. Now that's a constant in both directions, so it's a little bit different. Okay, so the integral from 0 to 1 of the cube root of t plus 1 over t plus 1 plus e to the negative t. So we integrate each of these. This is t to the 1/3 power, so it becomes 3/4 t to the 4/3. It's evaluated from 0 to 1 because it's definite. That'll go with I. For this one, it should be the ln of the absolute value of t plus 1. For this one, it should be negative e to the negative t. All of these are evaluated from 0 to 1. This one at 1 is just 3/4. So that means we have 3/4 I. This one at 1 is the ln of 2 minus the ln of 1, which is 0. So this becomes plus ln of 2j. When we plug in 1 here, we get negative e to the negative first. When we plug in 0, we get 1. So we have negative e to the negative first minus negative 1. So that would be 1 minus 1 over e, because this will become positive. This becomes plus 1 minus 1 over e. Okay. Lastly, it says find the antiderivative satisfying an initial condition. What we have to do is we'll have to take that c, d, and e, and we'll have to use it to our advantage. This is 3 dimensions. So what's the integral of cosine 2t? It's 1/2 sine 2ti. Integral of negative 2 sine t is positive 2 cosine t j. Normally, but remember what we have to have in here. Plus c I plus 2 cosine t plus d j. The integral of 1 over 1 plus t squared, you should recognize that as tangent inverse of t plus e k. Now, it said my initial conditions are this thing has to be 3, negative 2, and 1 at 0. So what's the sign of 0? So my c has to cover the 3. So we've got c equals 3. What's the cosine of 0? It's 2, or I mean it's 1, so it's 2 times 1 is 2. So 2 plus d has got to equal negative 2, so d is negative 4. What's the inverse tangent of 0? 0. So 0 plus e has got to equal 1, so e is 1. As a whole, we can substitute those values back in to get the actual function. It's 1/2 sine 2t plus 3, component 1 anyway. Second component is 2 cosine t minus 4. And the final component is tangent inverse t plus 1. And that is all for 12.2.